Hey everybody, it's Mr. Carr again. Today we're looking at 6.1 day 2. This is going to be covering the converse of the Pythagorean theorem. The first thing we're going to do though is before we talk about how we're going to use the Pythagorean theorem as part of today, we're going to talk about what's called the triangle inequality theorem. To form a triangle, the sum of two sides must be larger than the longest side. So in this diagram here, we usually use like if this is angle A, I'll call this lowercase a here. Angle B is going to create side B, and angle C is going to create side C here. So what this means, in our scenario, in this given diagram, B is the longest side. So I can see that I'm just going visually in this case. In order to form a triangle, that means that A plus C has to be greater than the length of B. So how does that work? We're just going to prove that triangles can be created from these different segments. So for example, can we make a triangle with 8, 3, and 5? So I always look at the two smaller sides. So that's 3 and 5. Does that come out to greater than 8? Well, that's 3 plus 5 is going to be 8. Greater than 8, that's a no. They do not form a triangle. Next one, my two smaller sides are 1.8 and 3.5. So it's 1 point, whoops, back here. 1.8 plus 3.5, is that greater than 5.2? Okay, so I got 1.8, sorry, 1.8 plus 3.5 gives me 5.3. Is that greater than 5.2? Yes, so we can form a triangle. Okay, and then for the next one, we got 6.1 and 4.2. We do 6.1 plus 4.2. Is that greater than 11.3? That comes out to 10.3, greater than 11.3, and that's a no. So the only one that satisfies the triangle inequality theorem is this one right here. Okay, so the other part of this with our inequalities is we're able to classify a triangle based on the Pythagorean theorem. So this is our actual converse of the Pythagorean theorem. So remember, Pythagorean theorem says if we have a right triangle, then the sum of the leg squares is equal to the hypotenuse squared. But we can work that backwards. If we have two legs and a hypotenuse, and C is always going to be the longest side. So this is important. C is the longest length every time. So if A squared plus B squared is equal to C squared, then the triangle is a right triangle. If it's anything besides that, so it kind of looks like this. So let's say I have a right triangle with a leg and a leg, and I make a hypotenuse here. This is a right triangle just like this right here. But if I do something like this, let's say I make, instead of a right angle here, I make it less than 90 degrees. Notice how that C, that length right here, has gotten shorter. That's our next scenario. If A squared plus B squared is actually greater than C squared, then the triangle is going to be an acute triangle. Okay? And then if I go the other way, let's make sure instead of a 90, whoops, instead of a 90-degree angle, I make it bigger than that. Well, now the hypotenuse length needs to get longer in order to complete that triangle. So what happens there is that A squared plus B squared is actually going to be less than C squared. That creates an obtuse triangle. Okay, so this is what we're going to do with the next part of this unit. First thing is, when we look at these types of problems, we want to make sure we can create a triangle. That's always step one. So when I look at my lengths, 15, 3 root 61, and 17.2. First thing I'm going to do is I'm going to plug in 3 root 61 in my calculator. So 3 square root of 61, and that comes out to about 23.43. So my two smaller lengths, 15 plus 17.2, is that greater than 23.43? We're always going to do this as a step one. That comes out to 32.2, greater than 23.3. That means, yes, it's a triangle. Okay, that's our first step. Then, to use our converse of our Pythagorean theorem, we're going to, for step two, we're going to go ahead and plug it into this. Basically, we're just going to do this. We're going to do A squared plus B squared compared to C squared. Remember, C is always the longest side. So in this case, that's going to be the 3 root 61 here. So I'm going to do 15 squared plus 17.2 squared. And let's compare that to 3 root 61 squared. So when you do this, make sure that you are doing this with the 3 root 61 and not the decimal number that I came up with, because sometimes you'll get an exact answer that does work out, but you won't see it because of the way it's set up there. Okay, so when I do that, I'm just going to plug this in my calculator. I'm going to get 549 here for 3 root 61 in the second power. 15 squared gives me 225. And then 17.2 squared gives me 295.84. So now I can combine these together. 225, and I get 520.84. That is less than the 549. So what that means is that a squared plus b squared ends up being less than c squared. So that means we have an obtuse triangle. Okay, so what we have is this scenario right here. The a squared plus b squared is less than c squared. Okay, that's what we're doing with our classifying to do that. For our last example here, we want to graph the points and classify this one. So we got x is at -1, -1 right here. Y is at 0, 4, so 0, 1, 2, 3, 4. Z is at 6, 2. 1, 2, 3, 4, 5, I guess 6, 2. Okay, so here is our triangle. So what I need to do is I need to find all these different lengths. So I'm going to do this with, I'll just do this with distance formula. So if I do xy, that's going to equal to the square root of, that will be -1 minus 0 squared plus -1 minus 4 squared. So that's going to come out to, that's -1 squared is a +1. That's a -5 squared, which is a +25 here. So that's equal to the square root of 26. Okay, so I'm just going to leave it like that for now. Then I'm going to do the same thing for yz. So yz, that's going to be 0 minus 6 squared plus 4 minus 2 squared. Okay, and that's going to be, that'll be a -6 squared is a +36. That'll be 2 squared, which is a +4. So that becomes a square root of 40. I'm just going to leave it like this because it, for my next calculations, it doesn't really matter if I break that down. And my last part is xz. So that's going to equal to the square root of -1 minus 6 squared plus -1 minus 2 squared. Okay, so that's going to be the square root of, this will be -7 squared, which is 49. So we have -3 squared, which is a +9. So that's a square root of 58. So this is going to be my longest side. So I need to test that. How does the square root of 26 squared plus the square root of 40 squared compare to the square root of 58 squared? Okay, so when I do this, I'm going to get 26 plus 40 compared to 58. And then I get 66 is greater than 58. So what I have is a squared plus b squared is greater than c squared. That makes this an acute triangle. So that's where my proof is right there. Okay, and that's it for today. That's basically our 2 parts to today's lesson. We first want to confirm that it is a triangle. So that's like step number 1 here. A plus b has to be greater than c. My 2 smaller sides have to be greater than the longest side. And once you do that, you're going to test out the converse of the Pythagorean theorem. Is a squared plus b squared greater than, equal to, or less than c squared? All right. And that's it for today. So take care, everyone.